All right, so these are going to be tripartite inequalities, and we're supposed to solve each one of them, and then graph each solution set, and then write the solution set in set builder notation. All right, with a tripartite, we have three pieces, hence the tri. What we want to do is we want to solve for the variable in the middle. And so to do that, we're going to add or get rid of the 2 here. So we're going to add a negative 2, or we're going to subtract 2 here. So we subtract 2 here, and we subtract 2 here. So when we do that, we get a 4 less than w less than or equal to 8. And so if we keep going down, we get that. Now, for the way this would be graphed, now, again, this one we don't even have to worry about. We just say, well, there's 8, there's 4, and let's do open circle and closed circle. So that's going to be an open circle. Oh, that's going to be a closed circle, and it's going to be everything in between. And usually you put it above the line, and that's what you get. And so this is going to be your set builder notation. And if you graph it, that's going to be what it is. So you have the bracket or the closed circle, parenthesis, or the open circle, and that's what it's going to be. And again, like I said, a lot of times when you're doing open and closed circle, you would do it above the line, so it's easier to see where your line is. And so that's kind of how that would look. But when you're doing it on computers, it looks different. So, but your set builder notation is going to be all W such that, and then you just rewrite this number or this notation right here. All right, what about this one? Well, here we have to divide everything by 4. So now we're going to have a negative 1 less than y less than or equal to 2. I guess there's a less than or equal to here. And so, again, what's it going to look like graphically? Well, if we go all the way down here, because I know it's going to write over it. So here's our 2, here's our negative 1. It's a closed circle like that. And then our notation is going to be y such that, and then we just write that there. So that's what we see. And again, that's what it would look like with brackets. This is what it looks like with the closed circles. All right, now this one is a little bit different. So what we're going to have to do is multiply everything by 3. So multiply that by 3, multiply this whole thing by 3, and multiply that by 3. So when we do that, we get minus 4, and that's less than 2 minus w, less than 15. And so then we have to go about solving this. And so we'll subtract 2. And so we have what? A minus 6 less than minus w less than 13. Now we divide by negative 1, divide by negative 1, divide by negative 1. Now remember, when you divide by negative, you better switch your sign. So that's going to be greater than and greater than. That's a negative 13, that's a w, and that's a 6. Okay, so now it says w is greater than a negative 13. So if we graph over here, here's a negative 13. Here's our 6. They're all open circles. So it's going to be less than 6, but greater than negative 13. So less than 6, but greater than that. So that's what it's going to look like. And then we're going to say for the other one, that's going to be kind of what it looks like there. So it's just showing you all the calculations it did to get to where it was at. And there's our thing. Now, see, they went and rewrote it a different direction, but it doesn't have to be that way. And so there's going to be negative 13 and to 6. Okay. So that's kind of what it looks like. All right. How about the next one? Now, or does something completely different. So it has to be either in this one or it has to be in this one. And so what we're going to do is we're going to solve for x basically. So x, subtract 3, you get negative 5. Subtract 3, you get negative 1. And so for this one, less than 5, if we were doing the open and closed circles, it's going to be everything that direction. And this one's going to be everything that direction. And because it's or, we're going to leave everything there. And so that's going to be our solution, the red and the blue pieces. Okay. And, it's not asking what is your notation or anything, but you could write it in different notations. One other way we could write it is it's going to go from negative infinity to a negative 5 union negative 1 to positive infinity, and that would be interval notation that we could use that way. So, set builder notation was one thing we did. This is interval notation. This is graphical notation, and then this is just, writing out what the solution is. So there's multiple ways we could be asked for to write this. So interval notation is another popular way on top of, the graphical. All right, and here we kind of showing the interval notation. Here's the number line graph, and here's what the inequality looks like. So these are just kind of different ways it looks like. So here, x is between -1 and 3. They're open, so it'd be parentheses, or, in this case, if it was actually graphed, it would be open circles. Here it's an open circle, closed circle, so it'd be open circle, and then a closed circle. Those are both closed circles, so that would be a closed circle, closed circle. Now here x is less than -1, so it's going to be open circle that way, or x is greater than 2, open circle that way. And here x greater than -1, so just open circle that way, and x is less than or equal to that, so it's going to be a closed circle that way. And again, all these are just kind of the different notations. And here u, again, what I used over here is union. So it means it's this piece or this piece. It's the union of the two. It has both of them included, okay? And again, brackets where there's equal to, parentheses where it's open. All right, so we're supposed to write each of these expressions in interval notation. So remember, this is going to be a bracket. This is a parenthesis, and so we have bracket -3 up to 7 parenthesis. This is going to be bracket 4 to positive infinity, and infinities always have a parenthesis no matter what side. It's either positive or negative. It's always going to have a parenthesis. Now here it's going to be less than -3 or greater than +5. So it's going to go from -infinity to -3 parenthesis union bracket 5 to positive infinity. So it's going to have two pieces. And again, you have to remember to put your brackets in and parentheses wherever they are, and then that union for the or. Now here, x is greater than 0 and x is less than or equal to 5. Well, this one is all it can be. So it's just between 0 and 5 is all it is. And it's parenthesis and then bracket. Bracket because of that, parenthesis because of that. And here, or, we're going to have another union. So it's going to be from -infinity up to 2 bracket, and then bracket 5 all the way up to positive infinity. Now, if you can't see it just directly, another way to do this is always graph it. So we can say on this one like this, we go from -3, we have 7, and this is open. Now x is between those two, and so then we put our closed circle there, and then we can see that, okay, we have a bracket and a parenthesis, and that's how we would get this one. Now, what about this one? How would we do that? Okay, well, here we have a -3. Here we have a 5. Notice I'm not marking out each individual thing. I'm just worried about in relation to each other, where are they? Now, it's less than -3, so it's an open circle that way. Greater than or equal to 5 here, so it's a closed circle that way. And now I can see, okay, well, -infinity up to the -3 parenthesis, makes sense, union. Now bracket 5 up to positive infinity. So sometimes you have to do things to make it work. Now this one with the or, again, you're just going to have the 2 and the 5, and less than or equal to that one, so it's a closed circle that way. And this is greater than or equal to, so I'm going to put it up here, closed circle, or that way. Okay, so that's how we can use graphical notation to get to here, and if we can't figure it out directly from our notation like this. All right, so here again, we're supposed to solve. So we add everything to one side and then divide if necessary. So here we're going to subtract 3, so that's a -6, divided by 2 is -3. Here we subtract 3 is 2, divided by 2 is 1. And so we have -3 to 1, and it's an or. And so again, if you have trouble seeing what to do, we have our -3 here, we have our 1 here, and it's closed that way, closed that way, and we can say -infinity to -3 bracket union bracket 1 to positive infinity. Okay, so that's kind of a thing. So if you can't go from here to here, go from here to the graph and then to here. All right, so that's all I have for this section. Hopefully that helps.